Hello everybody, welcome back to Music Impossible. This is Professor Jim, ready to get into lesson number 5 and continue our studies of meters and meter organization. And we're going to today study a little bit about the time signature and what that means. We're going to take our knowledge of duple, triple, and quadruple meter we discussed in the last lesson and add compound and simple meters and even some asymmetrical meters and how that all lines up. In the AP exam, you are going to have to recognize certain time signatures and be able to tell us if they are duple, triple, quadruple, and if they are simple compound. And usually there's some combination where they'll say, hey, 2/8 time. You have to look at 2/8 time and you'll have to say, well, that is a simple duple meter. And we're going to teach you how to do that today and identify those. Let's start off by taking a look at our time signature. What is a time signature, and what do each of the numbers mean? So that top number is going to represent the beats per measure, and the bottom number represents the value of the note that gets the beat. That bottom number, it represents a musical note value. So if there was a 1 on the bottom, that would mean a whole note. If it was a 2 on the bottom, it would mean a half note. A 4 is a quarter note. The 8 on the bottom, like 6/8 time, would be eighth notes. And we kind of sort of need to think about it in like a fractional form, if you want to think of it that way. All right, let's say we have 4/4 time. And let's pretend that, well, let's get rid of that top number right there. And let's replace it with just a fraction. We're just going to put a 1 over top of that. What's another way to say 1/4? Well, another way to say 1/4 is quarter. Yeah? So when the bottom number is a 4, it represents a quarter note. Let's do that same game again here. I don't know, let's do 6/8 time. Let's do 6/8 time. What if we take that 6 away and we're only left with the 8? And let's put a 1 over that, see what happens. That's another way to say that fraction. 1/8, right? So anytime we have an 8 on the bottom, that's going to be referring to eighth, A-I-G-H, eighth notes, and so forth and so on. We could do this all the way up to, I don't know, let's do 5. Let's try again. Let's do 5/64 time. That would be weird. So let's take that 5 away, and we're just left with 64. We'll put a 1 over top of that 64, and that's right. That would mean 64th notes. So that bottom number can only be a number that corresponds to a note value. We could have crazy stuff. We could have 15/8 time. That means there are going to be 15 eighth notes per bar. 15 is the top number. Eighth notes is that fractional representation there on the bottom number, the denominator, if you will. So it'd be 15th eighth notes per bar, per measure, per bar. Okay? So that's how we read our time signatures. All right, now we need to start thinking about how do we combine the idea of duple, triple, and quadruple meter with the idea of simple and compound. And what does that mean? A simple meter is one that can be divided equally into 2 parts. We'll demonstrate that on Sibelius in a minute. A compound meter is a meter that can be divided into 3 parts. And you see that the numbers you're seeing here is if the top number is a 2, that means we have a simple duple meter. Simple duple meter. If the top number of the time signature is a 3, we have a simple triple. If it's a 4, a simple quadruple. If the top number is a 6, 9, or 12, then we would have a compound duple, triple, or quadruple meter, depending on what that number is. Okay, let's come over here to Sibelius and let's examine our simple and compound meter ideas and how they pair up with our duple, triple, and quadruple meters. We'll start with this 2/8, and we know that the top number indicates how many beats there are per measure, in this case 2, and the eighth note gets that beat. So you'll see clearly right there we have 2 eighth notes, fills up the whole measure. Once those 2 eighth notes are done, we have to move on to the next measure. So this is very clearly going to be a duple meter, Now, how is that duple meter divided? Well, that's going to tell us whether or not it's simple or compound. We see that there are 2 16th notes per 1/8 note. So anytime the subdivision is 2 equally divided into 2 per beat, that is going to be a simple meter. So we're going to call this one a simple, we'll abbreviate here, a simple duple meter. And let's go over to the next one. We're going to look at an example of each of those. We have a 3/2 time here. In 3/2 time, they're going to be 3 beats per measure. 3 half notes in this case, 3 half notes per bar, 1, 2, and 3. And since these are equally divided into 2 parts, right, we have 2 quarter notes per 1 half note, 2 quarter notes to 1 half note. That means we're going to have a simple triple meter. Simple, let's see, we'll go simple triple meter. Simple triple meter. Okay? Now let's go to a simple quadruple. We'll go with an easy 4/4 time here, and we see that there are 4 quarter notes per bar before it starts over. The subdivision of those quarter notes is equally divided by 2 parts. That makes it simple. So this one is going to be a simple quadruple. I'm not going to spell the whole thing out, but you get the idea. So the distinction between simple and compound meters is the beat divided into 2 equal parts, or is it divided into 3 equal parts, like we're going to see here with our first compound meter? We'll go with 6/8. We see here that 6/8 is divided into 2 dotted quarter notes. One distinction about compound meters is the presence of dotted notes. Generally, the beat is dictated by some dotted note. Hint number 1 is dotted notes. Hint number 2 is the division of the beat is in 3 equal parts as opposed to 2 in the simple meter. So this one we would label, this is going to be a compound duple. Duple because it's 2 beats per bar. Compound because it's divided into 3 equal parts. The beat is divided into 3 equal parts. All right, let's take a look at the other two. We're going to have a compound triple here. Let's take a look at 9/4 time. And in 9/4 time, we see the presence of our dotted note here, dotted half note, 3 dotted half notes per bar. So we're going to have 3 beats evenly divided by 3 quarter notes per beat. Evenly divided by 3 quarter notes per beat. And then out here at the bottom, let's take a look at 12/16 time. This is going to be our compound quadruple meter. We see that the beat is divided with our first hint, right? The dotted 8th note. There are 4 dotted 8th notes per bar in this compound meter, and each beat is divided into 3 equal parts, 3 16th notes per dotted quarter note. So therefore, we're going to have our compound triple here, and then our 12/16 time down here is going to be compound quadruple, okay? Now, the AP Music Theory exam is going to ask you to look at time signatures and be able to determine whether or not it is simple or compound, and whether or not it is duple, triple, or quadruple. And you will label them as simple triple or compound quadruple, and you'll have to be able to distinguish between those. Let's take a look at a couple of asymmetrical meters, sometimes called mixed meters. Probably more commonly used is the term is mixed meters. The exam may call them asymmetrical meters, and these are those that aren't really evenly divided by anything. So 7/8 and 5/8 are the most popular, and you can see some examples of those here. We have a 7/8 bar, and they're generally grouped in series of 8th notes. This one is 3 plus 2 plus 2. You can see how they're beamed in a way that separates them. And sometimes you'll see a 7/8 bar where the composer or orchestra arranger may even tell you what the division is for this particular time signature, 2 plus 2 plus 3, and then you can see the groupings, 2 plus 2 plus 3. So oftentimes there's a little bit of an accent on the beginning of each of these groupings. Or same thing with 5/8. We're just taking away 2/8 notes. Or 7/8 and 5/8 are some asymmetrical time signatures. I always like to share with you and learn a little bit about different asymmetrical meters in different places. I got a couple of videos I want to show you here. Let's go over to the land of YouTube. And we come over here. We're going to take a look at a song by Led Zeppelin. And here it is, a song by Led Zeppelin here. You can see the tab. I'm going to rewind it just a little bit so we see the beginning of the tab. We have a bar of 4/4 followed by a bar of 7/8, bar 4/4, 7/8. And anytime we have these meters, the 8th note is going to stay consistent as far as its length. So the tempo doesn't change relative to the 8th note. So if I'm in 4/4, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, dot, 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 dot. When I get to the 7/8 bar, I'm going to keep the same pace with those 8th notes. I'm just going to have 7 of them instead of 8. So here's a bar of 4/4 followed by a bar of 7/8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 1. And that's how this works. This particular piece has a grouping of 2 followed by 2 followed by 3. So 2 plus 2 plus 3. Let's take a listen to this a little bit. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 1. So then it goes into 4/4 time for a while. There's another option or another example of this. It's a piece of music I recorded with some members of the Baltimore Symphony Orchestra. It's just a piano solo piece, and it's also in 7/8. I want you to listen to it, see if you can pick up what the division is. It's a little more subtle in this piece. Take a listen. All right, so what do you hear there? What kind of subdivision are we hearing? Most of it it's a little more subtle than a lot of mixed meter pieces, but this one is generally in the 3 plus 2 plus 2 category. Especially when it starts here with this English horn. 1, 2, 3, 1, 2, 1, 2, 1, 2, 3, 1, 2, 1, 2, 1, 2, 3, 1, 2, 1, 2, 1, 2, 3, 1, 2, 1, 2. And then the main melody here, same thing. 1, 2, 3, 1, 2, 1, 2, 1, 2, 3, 1, 2, 1, 2, 1, 2, 3, 1, 2, 1, 2, dot, 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 dot. All right, so there's just a couple examples of some 7/8 time. All right, that's our lesson for the day. We're going to head on over to some looking at duples and triples. We're going to introduce some fancy words like anacrusis and talk a little bit about syncopation in both jazz, ragtime music, and classical music as well in our next lesson. All right, you have some worksheets to do. You have a quiz from the last 2 lessons coming up today. Good luck with those, and I'll see you next time.